Hi, good morning all. Today I am going to talk about two energy rich products and high in vitamins. That is, one is milk and the other is honey. Let's see, we'll focus on the importance of this product in a scientific manner and how we use this in an adulteration free form. Okay, before this topic, students, I would like to express some thoughts on education. It's the fact that education shapes the life of an individual. An educated person can interact with anybody, moreover, he is respected everywhere. So, friends, I humbly request you to be conscious of your education first. So, we in science also should be aware of the power of imagination. Imagination is more important than knowledge. That's what Albert Einstein said. Every creation is the result of imagination. You cannot create anything new without being imaginative. So imaginative people are always inquisitive. Single-minded concentration helps imagination to become a reality. So alternative thinking is the hallmark of imagination. So students, to have innovative concept, we also should be imaginative. Okay, let's come to our topic. First one is milk. We'll see what are the components of milk in a scientific way and what are the procedure should take care in the processing section, and also how to use this in an adulteration free form. Okay, first one, milk. We can say in a scientific manner, that is Food Safety Standards Authority of India, that is FSSAI. The definition is milk is a normal mammary secretion derived from the complete milking of healthy milked animals without either addition thereto or extraction therefrom. It shall be free from cholesterol, okay, and it shall conform both the parameters of milk fat and milk solid not fat. That is SNF, milk solid not fat. So we'll focus on the composition of milk. Composition of milk will divide it into two major parts, that is major milk constituents and minor milk constituents. In major milk constituents, what are these? Is water is the main part, and fat is the variable components of milk is fat, and milk protein, lactose, that is carbohydrate part, minerals. These all are the major milk constituents. So we'll see in detail each one. First one is water. We all know that it is a medium in which other components of milks are dissolved or suspended in it. It varies in the range of 83 to 87% depending upon the species, upon the breed, like that. Okay. A small percentage of water in milk is hydrated into lactose and salts. Next one, fat. We all know that it is a variable constituents of milk. It ranges from 3 to 8%, like that. Exists in the form of small globules. So we all know that it is a fatty acid, triglycerides with a glycerol, and that is a chain formation. It is composed of a number of glycosidic esters of fatty acids. On hydrolysis, milk fat furnishes a mixture of fatty acid and glycerol. In fatty acid profile, milk fat, that is the triglycerides of fatty acids, which make up to 95 to 99% of milk fat, that is fatty acid profile. Other portion are composed of diglycerides, monoglycerides, etc. Next, cholesterol part, its content is affected by the species breed, feed, stage of lactation, and season of the year. In phospholipid part, the total phospholipid content may varies from buffalo milk that is 21.04 milligram per 100 ml of milk. In cow milk, that is 33.71 milligram per 100 ml of milk. Next constituents, milk protein. Yeah, what is protein? We all know that it is the major type of milk protein present in milk is casein. It's casein, and also we have beta-lactoglobulin, beta-lactalbumin, etc. Casein is the principal protein that is make up to 80% of total protein content, and remaining 20% is whey protein. So lactose, it is the carbohydrate part in milk. It is the major carbohydrate part. Milk is lactose. That is, we all know that it is a disaccharides. That is constituents of D-glucose and galactose. It is a monosaccharide unit is D-glucose and D-galactose. And buffalo milk contains milk that is varies in 4.7 to 5% of lactose, and cow milk contains around 4.5 to 5% of lactose in it. Next one, minerals. We measure mineral part that include the potassium, sodium, magnesium, calcium, phosphorus, citrate, chlorine, sulfate, bicarbonate, etc. It is a very small part. Average normal milk contains 0.7% of ash, that is minerals. Next, we can see the minor constituents that are the minor amount of present in the milk, that is enzymes, vitamins, pigments, etc. Okay. In vitamins, we can see in this chart what are the vitamins present, vitamins, thiamine, riboflavin, nicotine, biotin, pantothenic acid, like that. This chart says the average vitamin components in milk present. We can see that buffalo milks containing high amount of vitamins compared to the other milk, that is Indian cow, exotic cow, like that. Okay. Enzyme, we all know that the enzyme, in the processing point of view, we can divide it into alkaline phosphatase, lipoprotein lipase, protease, lactoperoxidase, lysosome. We all know the alkaline phosphatase, that is in the temperature at which it is inactivated and the temperature employed for the pasteurization of milk, we can use this, identify the alkaline phosphatase content. Okay. Lipoprotein lipase, that is the fat splitting enzyme. The residual activity of lipase remains in the processed milk or milk product, tends to reduce their shelf life. Proteases, the other enzyme, residual proteolytic activity in processed milk and the milk product reduce their shelf life. And also lactoperoxidase, activity in buffalo milk, that is ranges to 5 to 2 to 9 to 8 units. In cow milk, that is average to 4.4 to 7.2 units per ml. Lysosome, it is a small peptide chain, we all know that. Its content of cow milk is about 30 micrometer per 100 ml of milk. In pigments, in cow milk, the major pigment content is carotene. Carotene that gives the yellowish tinge to the cow milk. In buffalo milk, we all know that it is not in yellowish tinge. It is a white color. White color, isn't it? Yeah, white color. Because this carotene is converted to vitamin A. Carotene is converted to vitamin A before passing into the milk, so it appears white. So in cow milk, we can see the yellowish tinge. This is because of the presence of carotene. In buffalo milk, white color appears. This is because of the carotene that is converted into vitamin A. Physical property, we all know that the appearance, milk color varies to white to yellowish tinge. Flavor, it is composed of smell and taste, acidity and pH. That is normally in range between 6 to 4 to 6 to 6 in case of cow milk, and 6 to 7 to 7 in pH range. That is in the buffalo milk. That will varies in that. And acidity, titratable acidity is varies to 0.1 to 0.14 in cow milk and 0.14 to 0.15 in buffalo milk. Density and specific gravity. We all know that density is the substance weight per unit volume. That is density. So we use lactometer to calculate, or is the parameters to calculate the density of the milk. Specific gravity is the ratio of density of a substance to the density of water. Compared to water, we can calculate the density of milk. The density of milk can be determined by lactometer. So the specific gravity of the milk, that is in ranges to 1.028 to 1.030 in cow milk, and buffalo milk is 1.03 to 1.032 in buffalo milk range. Microbiology of milk. We all know that milk drawn from the healthy animals, that is free from any bacteria. So we should examine the bacteriological study, and it should be free from all the bacteria. So the microbes capable of spoilaging of milk present in the environment. So milk has to be protected. So unprotected milk is protected carriers of diseases and microbes. Bacterial growth in milk can be retarded by, we can reduce by refrigeration, or in cold condition we can reduce it. Pasteurization, we will see in pasteurization detail. This will help to eliminate the bacterial content or any bacterial infection, bacterial content of the milk has to be eliminated by the process of pasteurization. The more heat-resistant pathogens, namely Mycobacterium tuberculosis and Coxiella burnetii, like that. Okay. Milk and public health. What are the possibility to infect or contaminated in contaminated milk? That is, infection of milk directly from the cow is a possibility, and infection from man to cow and then to milk. So direct contamination of milk by human beings, indirect contamination of milk by human beings. So we can see in detail that from the collection point of view to the transportation level and the processing section, all we have to thoroughly examine the quality analysis of milk. So it should be free from all the adulterant. So we have to follow the hazard analysis. Critical control point should be monitored, and we have to make sure the absence of any contamination in milk. So in milk, the two main parameters we already told, that is milk fat and milk solid not fat, that is SNF. In milk fat, we can see in cover that the ranges according to the milk fat, it is named as skimmed milk, toned milk, double toned milk, because in toned milk we can see 3% of fat, 3% fat level. Double toned, it's 1.5% fat. Skimmed milk, the fat very low in fat, that is 0.5 to 2% of fat present in that skimmed milk. Okay. Next one, solid not fat, that is solid part of the milk. In toned milk, 8.5% should be there. In double toned milk, 9% should be there in milk, that is solid, not fat, SNF. Okay. So, sorry, sir. Okay, right. Okay, next we go to the grading of milk. How we can grade the milk. So in this, we go for the platform test. First one is the platform test. So from the collection point of view, you already told that from collection point of view to the transportation level, so the adulteration should be nil and it should be free from all the adulterant and also adequate hygienic pattern should be followed. Okay. So in platform test, to check the quality of incoming milk, to make quick decision regarding its acceptance or rejection. Then next go for the adulteration test to detect the adulterant or routine conductly or for the quality assurance we have to perform the adulteration test. Next one, confirmatory test. Apart from the initially accepted or rejected lots of milk, there are always some with doubtful quality. So it has to be confirmed, that it has to be tested in a quality control lab. Next one, that is the milk processing point of view. We can see that from the collection point, collection of milk from that cow or buffalo, then we transferred into that in the processing section we can see this is a flow chart. So first we have to pump into the big silo like that. This one is silo. So where we collect the milk. Next we go for the cooling purpose. That is below 4 degrees we have to cool it. Then testing and measuring the quality again. We have to monitorize this one, testing and measuring the quality. In milk processing session, we can see first of all standardization, separation, pasteurization, homogenization and storage. So in standardization, we found that the two components of milk, that is milk fat and SNF, should be standardized. In toned milk, we see that there should be 3% of fat and SNF should be 8.5%. So we have to standardize the milk according to the FSA, that is Food Safety Standards Authority, 2006, Act 2011. We have to make sure the fat and SNF. So we go for the standardization process. Then homogenization means we can use homogenizer to homogenize fat globules present in the milk and equally disperse the fat in the milk. Next one we go for the pasteurization. Pasteurization, we all know that heating of every particle of milk in a certain temperature, then after immediate cooling. That is pasteurization to eliminate the microorganism present in the milk. So it should be free from the microbial contamination. We go for the pasteurization. Next we go for the storing, then packing like that. Okay. And also the other product of milk, we can see value added product of milk, ghee, butter, like that. Storage. And next one we go for the quality checking, quality analysis of milk. That first one, platform test. We already told that platform test to make sure the quality of milk, that is organoleptic test, smell of milk in the container immediately after removing the lid. We can, in case of abnormal smell or something like that, reject the milk samples. Okay. And observe the color of the milk and examine the milk. Next other one is Croton boiling test. We take 5 ml of milk and keep the test tube in a boiling water bath for 5 minutes and remove the test tube and examine the side if any precipitate it is present in the tube. We see that it is a positive result and indicates the positive result, and we don't go for the titratable acidity above 0.17 percentage. So milk which gives a positive result generally above 0.17 percentage of lactic acid, and it is not suitable for the distribution. Another test is MBRT test, methylene blue reduction test. It is we use a reagent methylene blue, take 10 ml of milk in a test tube, add 1 ml of methylene blue in a solution, keep the tube in a boiling water bath for 37 degree and inspect and record the time at which the decolorization will see if the color persists. This is the blue color, indication of blue color. If the tube is found not to be decolorized within 30 minutes, the sample satisfies the test. The sample is okay with that. We have to look into the test tube that the decolorization not to be found decolorized within 30 minutes. It's positive for the MBRT test. Next, acidity. Titratable acidity, we use the reagent sodium hydroxide, phenolphthalein, that is the indicator. So what are the procedure? 10 ml of milk in a tube, take 10 ml of milk and add equal amount of distilled water in it, add 2 to 3 drops of phenolphthalein indicator, and titrate against 0.1 normal NaOH solution in a burette. Okay. Then we can go for the calculation, that is 9 into V1. It is the burette reading, and N is the normality of NaOH present. See, we normally use the 0.1 percentage, 1 normal NaOH solution divided by V2. That is the volume of milk we taken, that is 10 ml. It's a titratable acidity we calculate. It's around, it should be around 0 to 11 to 0.17 percentage. Beyond it is not so suitable for the consumption purpose. Next, another is how to determine the density. We already thought this is the lactometer. So lactometer is the device to measure the density of milk. So place lactometer in the milk. So note the temperature at which the lactometer reading of the milk and find out the corrected lactometer reading, that is CLR. So CLR is the LMR, that is the reading at which we taken divided by the temperature, that is calibrated temperature around 29 degrees is the normal temperature to correction factor, that is 0.13. So density we calculate 1 plus CLR, that is corrected lactometer reading, divided by 1000. So we can see the density of milk by using lactometer. Next one, how to determine the fat. This is one of the important tests to calculate the fat percentage of milk. So this is the butyrometer. You can see this is a butyrometer. Is a device to detect the fat percentage of milk. This method is known as Gerber method. Gerber method is a procedure measure 10 ml of 90% sulfuric acid into the dry butyrometer and 10.75% of milk. Pipette out this 10.75 ml of milk into the butyrometer and also add pipette out 1 ml of amyl alcohol into the butyrometer and close the neck with stopper and shake butyrometer carefully to mix the content and centrifuge the butyrometer at a speed of 1000 to 2000 RPM for 4 to 5 minutes and take the butyrometer reading. In this we can see the 2 layers. So the upper layer is the fat. So we can measure the fat column and calculate the fat percentage of that milk. So what is the principle behind this? That in fat that is dissolved fat dissolved in the amyl alcohol, that forms one layer, and the other components of milk that is dissolved in the sulfuric acid in the other layer. So we can see the two layer and measure the fat percentage. We can see in detail in lab. Okay, when that time we should know the exact how to calculate fat percentage. Next one, how to calculate not fat, that is solid not fat particle of milk. That is by calculating lactometer, we can see the SNF, that is solid not fat. That is the equation is CLR, that is corrected lactometer reading plus 0.2 into fat. What we see in the Gerber method, we can substitute that value into here, divided by 4 plus 0.5, that is the SNF, solid not fat percentage of milk. Then we can calculate total solid after that. Total solid means fat percentage and SNF percentage of milk, that is total solid. So that is a total solid percentage of milk. We already told that the milk should be adulterant free. We have to check the adulteration test. So commonly found adulterant, that are the first one. How to detect the adulterant starch in milk? So in this we use reagent iodine. So the procedure is take 5 ml of milk in a test tube, boiling with that in a flame and cool it into the room temperature. Add 1 drops of iodine solution in it. And presence of starch is the appearance of blue color. Blue color is present. It is a positive test for starch, and that is the presence of starch in milk. We can see if blue color present in milk. Okay. So that is a detection of starch. Next one is detection of cane sugar. If I added we can perform the test. So we need reagent concentrated hydrochloric acid HCl, resorcinol. In procedure, take out 5 ml of milk in a test tube, add 1 ml of hydrochloric acid and 1 gram of resorcinol and mix thoroughly. Heat tube in a boiling water bath for 5 minutes. A red color is present. In the tube. We can say it is a positive test for the cane sugar. Next adulterant, we can see formalin. So in this we use concentrated sulfuric acid as a reagent. Take 10 ml of milk in the test tube. Then add some volume of concentrated sulfuric acid around the side of the tube, and it forms, if the formaldehyde or formalin present, it forms a layer at the bottom without mixing the water. So it is a violet color layered will form. It is indicates the presence of formaldehyde. That is formaldehyde test. Next one is neutralizer. If we use the sodium carbonate, sodium bicarbonate, we can go for the test, neutralizer test. That is the main reagent is oxalic acid reagent used. Take 10 ml of milk in a test tube, add 5 ml of alcohol and 10% of oxalic acid, mix thoroughly. If carbonate is present, rose red color will appear. That is for the positive test for the neutralizer, that is carbonate or bicarbonate present in it. Okay. So in conclusion, we can see what we studied, all those things. Okay. So in conclusion, so in milk, we already എങ്ങനെ സാറ് പറഞ്ഞത് നിർത്തുന്നത്, എങ്ങനെ കൺക്ലൂഡ് പറഞ്ഞ് നിർത്തണോ അതെയോ ഇത്ര ഓക്കെ. So these all are the part composition of milk we studied, and what is the we see what are the definition of milk in a food safety standards authority, how we use this in a proper and scientific manner, and what all are the procedure we see in detail to detect the adulteration present in the milk. So we can conclude for the time. ഒരു ടോപ്പിക്കോട് എടുക്കണം സാറേ, ഇത് മതിയായില്ലേ?